A little, well, more notebook, I guess, so to speak. Yeah, we'll see. I'll explain. So here's the potential game plan for today. Number one, we just wrapped up the imitation game. Very sad ending, but you know what? That's real life, unfortunately. The thing that I really love is that at the end of the movie, they talked about these Turing machines, and today we refer to them as computers. Obviously, it's a bit more complicated than that. Computers nowadays, like the reason why Steve Jobs and Bill Gates are given like such like adoration is because of their work with the personal computer, being able to like minimize the size of these things. Because basically, what this computer in front of me is doing right now, if Turing were to build something equivalent back in the 1940s, the size of that computer would be like the size of the school building. Possibly, yes, I know. But it's because of, there's actually this interesting theory about there's an inverse relationship between the advancement and speed of technology and the size of that technology. You know what I'm talking about? Does no one know what I'm talking about? I don't know what he's talking about. It's just water. Yeah. Listen, as technology gets faster and faster and faster, the size of that technology is going to get smaller and smaller and smaller. There's an inverse relationship. They're already talking about like quantum stuff. Maybe. Great movie. Nice connection. Yeah. Oh, Ant-Man and Quantum Mania and the fact the multiverse and Anyway. Really?
Yeah. We're trying to make a cap that you put on. It's like
oh gosh, that takes me back. I'm thinking Back to the Future.
Do you know that one episode of the Black Mirror?
I didn't watch Black Mirror. No. I watched a couple episodes and they made me feel bad. And I was like, you know what? I don't want to watch stuff that is just going to make me feel worse. I want to watch stuff that's going to be like, wow. Mm-hmm. Sure. Sure.
It's a hat, like a motion capture hat, that lets you feel the pain of the person the other one is connected to.
Yeah, no thank you.
So a doctor gets it.
Yeah. Yeah, I'm listening.
He can diagnose what he has to fix.
That's true, but I can see the rationale behind that, but still, no thank you. Yeah. Anyway, here's the rundown for today, though. So we just wrapped up the imitation game. I do have some multiple choice questions for you to kind of, it's an assignment that I'm going to give you near the end of this class period, just kind of wrapping up the imitation game. Now, you could answer those questions on your own, obviously, but if you do need, like, oh, I don't really remember that, of course, Google can be your best friend to kind of knock that thing out. I'm not asking everyone to like just go rewatch the imitation game 3 times so that you know how to answer all these questions.
Google can do that. You watch the whole movie, no skipping.
I know. Anyway, but yeah, that's that's on you. But I'm going to assign that before the end of this class period. We'll get that done. I do have just a couple Enigma Phase 2 problems for you. I say a couple because 2 of them I do need to remind you as to how to do them. One of them is the Veneer squares from earlier in the semester, and the other one is the Playfair cipher, the one that they did in National Treasure 2. So one of several, yes, I know. But anyway, yeah, so we're going to have that. Then my main goal for today is to continue working with the Affine cipher, the thing that I introduced to you last class. So that's actually where we are going to start. So you asked me what type of day it was. I was just trying to think in my brain, like, what type of day is it actually? So what we're going to... It is a nice sunny Thursday. I am going to start with those notebooks. So if you do not already have them out... I'm going to need those notebooks out and open.
Yesterday, it was so on and off. Yeah. Like it'll be pouring and like 5 minutes later, it's like nice and sunny.
Yeah. Well, the thing is, I'm going to crack the door open a little bit just because it is getting warm in here. It was interesting because yesterday I was out. I was actually proctoring an AP test. And you would think like, oh, proctoring an AP test. These are AP students. You'd think that they'd be giving these students as much like, like, okay, you're taking an AP test. I remember when I took an AP test in high school at Southern, they had us like in the board office in this like comfy kind of conference like area that was large. Metal chairs in the trailer next to the Collins School. So I'm proctoring this test. I wanted to get in there at 7:15, make sure everything was good, set up all my materials. The students would start showing up at 7:30, get them all settled, go through the directions, start testing at 8, right? Simple. I'm there at 7:15. The guy who's supposed to unlock it is not there. Just standing there. I found, after a few phone calls, I found out that the guy who was supposed to unlock it called somebody else and left them a message so that they would unlock it. Didn't show up. So eventually, Miss Gerke, after I got in touch with her, she drove over to the trailer just to unlock it, only to find out that that guy who got the message finally showed up. We're standing out there for 20 minutes as students are showing up. Like, sorry, guys, you can't take your advanced placement English test because nobody unlocked the door because they pushed us out of the school into this trailer, although they can afford, a brand new football field turf and a concession stand. It is a concession. I said that to my AP class this morning because they're taking theirs at the end of the month. And the one kid's like, why don't we opt to take our test in the concession stand? I'm like, it probably would be better circumstances. Anyway, back to this.
I just don't get like they couldn't just set aside like a classroom or something.
Yeah, their logic behind it was that the bell schedule would mess the kids up, or kids in the hallway would be a disruption. You've been taking AP testing for like 20 something years, and now this is the year that you're concerned about people like you're going to distract you. Yeah. Goodness gracious. Oh, good. Oh, sorry, Sky. I just read your comments. It's no more enigma. Okay.
Yeah, the bell ring made me feel,
Yeah, they do. They go outside.
They're like the people that do have recess.
It's like the only exciting part of the day.
Yeah.
Because I was like, real. Yeah, but like, what if it's raining? Is it like indoor recess?
Yeah, then you go indoor recess.
Yeah. You ever gone to elementary school? Yeah.
I've been to elementary school. I wish we had recess.
Okay. I want to give you an idea or a reminding of the multiplicative inverse for modulars. And then I'm going to go into the example that we're going to do today. So this is the multiplicative inverse for modulars. Now, you guys in general already know what a multiplicative inverse is. You already do. For example, if I were multiplying by 11, how would I invert that? You divide by 11, yeah. Or better yet, if you're multiplying by 11, how can I get rid of that by multiplying? No, I'm sorry. You multiply by 1 over 11, right? You multiply by the reciprocal. Absolutely. But unfortunately, you cannot multiply by reciprocals when you're dealing with modular arithmetic. We're trying to deal with multiplicative inverses here. So it's like, one example that I can kind of show is something like this, where we have, I don't know, like 7x equals 15 mod 26 or something like that. There we go. And the thing is, it's like, okay, I can't divide by 7 here. I can't divide by 7 here, mod 26. Yeah, I get a decimal. But I have to somehow get that 7 off of the x. I have to solve for x here, right? So I have to figure out, okay, what I need is some kind of inverse to 7 times 7 that is equal to 1 mod 26. That's actually what I need. Because if I can figure out what that inverse of 7 actually is, it will cancel out the 7 on that variable. Because you're just like, oh, divide by 7, but I can't get decimals. 15 divided by 7 is a decimal. So I need to find a multiplicative inverse for modulars. And this is kind of what we talked about last time. I think I changed up the numbers a little bit, but that's okay. Last time we talked about this using that mod 26 chart. So I'm going to go to my mod 26 chart. Let's see. Before I give you a couple challenges for today. There we go. Mod 26 chart. Let me open that sucker up. Come on, little thing. Load faster. There we go. So let's see. The way that this multiplication table works is actually quite ingenious. Check this out. I'm just going to walk up to the board real quick, casually. You guys did like multiplication charts back in elementary school? Remember them? Or it was like, I think you did like up to maybe like 12 or some junk like that? Yeah. Yeah. And you'd match the numbers and then go to the middle and then, oh, that's what they multiply to, right? Yeah. You see them in the back of like composition notebooks and whatnot, right? Look at this. Look at this right here. 2 times 4 is 8, right? Yeah, it works exactly like a multiplication table. It's exactly what it does, except the table is mod 26. Yeah, now clearly 9 times 9 is not 3. Hold on. But in modular it is, because 9 times 9 is 81, but you do 81, and some of you have your Chromebooks open, so do this for me. You could do this one of 2 ways, but you could do, let's see, minus 26, minus 26, minus 26. I think that will do it. Did it work?
That wasn't did not bring me to the calculator. It brought me something about the Don't ask me. I just worked.
Okay. But it worked to 3? Yeah, it worked to 3. It equals 3. Because this whole thing is mod 26. Now, when I'm talking about my problem here, let's see. Let's go to the 7. And on the 7 row, where do I get a 1? 15. If you go to the 7 row, supposedly 7 times 15 is equal to 1 mod 26. That's the way that thing works. So in reality, this 15 is the multiplicative inverse that we are looking for. That 15 is indeed the multiplicative inverse that we are looking for. So if I go back to this little piece of notes section that I got going on here, boom. Instead of 7 inverse times 7, I'm going to go 15 times 7 is the equivalent of 1 mod 26. That's the number that we would need. So instead of, oh yeah, that's just to get the x by itself. And I'm going to show you how that works with an example in a few minutes, because I'm going to have you guys decoding and encoding stuff. We were originally trying to solve this problem. Mod 26, but in order to do it, we have to multiply by 15. If you multiply both sides now by 15, what happens to 15 times 7, mod 26? What happens to 15 times 7 mod 26? Something. Not just something. Right here. What's 15 times 7 mod 26?
1.
It's just 1. According to that chart, it's just 1. So we get x equals 225 mod 26, and then we would just have to reduce down the 225. It is a sick process. It takes a little bit to get into it. It takes a little bit of getting used to it. It's like jumping into a cold pool. You get used to it after a few minutes. Or you drown.
Booyah.
On my calculator, I'm going to go 225 divided by 26. I'm going to get rid of the whole number, and I'm going to multiply by 26, 17. This is the equivalent of 17 mod 26. Okay. Whistling.
Gotta get their attention.
That's true. Oh, so check this out. You really want to see something messed up, though? I'm going to go back to that mod 26 chart in a moment. I'm just going to leave this up here. It's really going to be messed up. Look at the original problem. The original problem was 7 times what will give you 15? Right? Mod 26. 7 times what will give you 15 mod 26? And ultimately, we found the answer was 17. Right? So I'm going to go to the mod 26 chart with these two numbers. And the result should be 15. Watch this.
There's no way.
Oh, yeah.
Of course there's a way. 7 times 17, 15.
It's a multiplication chart, but if it goes higher than the mod, you mod it and you get a number lower.
Oh, okay.
Exactly. The whole chart is a mod 26. But it's literally acting like a multiplication chart. Yeah. That's true. But you can always mod it down. Yeah. It's sick. It's absolutely sick. Yeah. Pick like for example, just for the sake of argument, pick two digit numbers that are on either the first column or the first row of this chart. 20 and 24. Go to your calculators and do 20 times 24. Oh, that's 480, right? Yeah, you just do that in your head. Like, what am I even thinking of?
Yeah, I just want to do that in my head.
Yeah.
Yeah.
Well, dude, just think about it. It's like you're doing 0 times 24 and then 2 times 24, which is 48, but it's really with an additional multiple of 10. Do it in your head.
I wasn't thinking about that. Calculator. Oh.
Yeah. So I'm going to go, again, calculator. I'm going to reduce this 480. 480 mod 26. Get rid of that 18. Multiply with 26. The answer should be 12.
I hate how that just works.
Yeah. So then 20 times 24. 20 times 24. Gives you that 12. I know. But that's how this multiplication table works. It's kind of nice. So now, knowing that piece of information for the Affine cipher, let's go back to what we were attempting to do the other day. Now, we were trying to decode the word hello. I am going to give you a long, kind of a long cipher, a long-ish cipher. I'm going to give you a long-ish cipher. And we are going to attempt to decode it. Actually, no, I'm not going to give you that long one just yet. That long one is a challenge. I'm going to give you a shorter one. I just decided midstream. Sometimes my thoughts go in all sorts of directions. Let's give you this one. Come on, zoom out, zoom out, zoom out. Here we go. So here is the ciphertext. The ciphertext that I'm giving you is LOYIVQ space JCW. Well, here's the problem. Frequency analysis works if you have enough letters. This is not enough letters.
There's no frequency.
And then the affine numbers that you need are 21, 2. Knowing that it's 21, 2, and knowing that it's an affine, the function which changed all of these things around should be 21x plus 2. Remember, the k value, that first number, has to have nothing in common with 26. Which is fine. Yeah, which is correct here. And then the second number, it could. Yeah, because the first number is the multiplicative, and the second one is the additive. The first one is that multiplication chart, mod 26. The second one is basically a Caesar shift. So that's what's happening. Now, we have the cipher, but this is the function that actually made it work back, made it ciphered in the first place. All of those letters, A to Z, were corresponding to a number 0 to 25. In fact, again, it may always be helpful to just kind of do something like this real quick. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T. It's my new tune. U, V, W, X, Y, and Z. It is. Josh wrote it. I didn't pay you. Wait a minute. Oh, I totally messed up. How did I mess up? How did I mess up? How did I mess up? Yep. I did not put the 0. 0, 1, 2, 3, 4, 5, 6, 8, 9. What's the Marquee Classic? Oh, the mess up. I have no qualms about messing up. It's what everyone does. It's just you have to catch your mess ups. That's the key.
Unless you're a meteorologist, then you can just say,
That's true. No, but I'm just saying, honestly, for like high school students, most of the time, like they make a mistake and they fall into one of two categories. They either realize it or they don't, right?
Yeah.
Now, if you don't realize it, it's like, oops, okay. But if you realize it, some high schoolers are like, whatever. You're laughing, but you know it's true. You have to be able to, number one, admit your mistakes, and number two, correct your mistakes. Anyway, back to this. So, L. L, the first letter in this thing was the number 11. It's like, okay, well, if I'm going to solve this, it's like I got to plug 11 in for that L. That 11 is going to go here for the f of x. It's going to equal 21x plus 2. Now, logically, you would say subtract 2 and divide by 21, right? But we get a decimal, which we can't do that. Now, I am going to subtract the 2. It's going to get me 9. 9 equals 21x. But this whole thing is mod 26. I can't divide by 21. I'm going to have to figure out, okay, 21 times what will give me a 1?
wow.
21 times what? Exactly. Exactly. You go to the chart. 21 times what? There's 21. There's the 1. There's the 5. The multiplicative inverse is 5. The multiplicative inverse is 5. So, if I want to get x by itself here, I'm going to multiply both sides by 5, which is the multiplicative inverse of 21. It's going to get me 45 equals x, but keep in mind that's still mod 26. It's still mod 26. So 45, I'm going to have to reduce it. 45 minus 26 gives me 19. What is 19 as a letter? And I have them written on the board just for reference. It's a T. So that word, the LOYIVQJCW, the first letter, in the plain text should be a T.
I mean, to do this for each letter.
Yes, but all of the work that I wrote out here is not entirely necessary. It's not entirely necessary. In reality, I'm going to show you how you can organize this in a moment. You ready? Here's how you can organize it. Yeah, it was a moment. Did you enjoy your moment?
Yes, I did.
Now, this is, just one way of doing it. You don't have to do it this way. If you have better ways of organizing this information, by all means, do it that way. But I just wrote all my letters out like that. This L is actually what? An 11, which means it should be 11 equals 21x plus 2. Now, because of the way that this works, I know that I'm going to have to use the multiplicative inverse of 21, which we already found out was 5, right? Yeah. So in reality, you're going to be subtracting 2 and multiplying by 5. And since you're subtracting 2 and multiplying by 5, you get 45. Because 11 minus 2 is 9, and then 9 times 5 is 45, which reduces to 19, which is the equivalent of T. Hopefully you can see that little flow right there. You don't have to write down all of that work. You just have to figure out what each individual letter is. Yes, when you get to that equation, 11 equals 21x plus 2, you're going to have to subtract 2 to get 9 and then figure out the multiplicative inverse, which again, it's going to be the same multiplicative inverse for all of these because 21 is that k value. I got that 45. I reduced the 45 mod 26. I figure out what that plain text letter is. So I'm going to give you guys a little bit of time here. I want you to decode this. Figure this sucker out. Figure out what that phrase is supposed to be. I'll give you maybe less than 5 minutes.
Sure. They showed it going through the machine twice. Did it compound 6 times or 3 times?
Good question. Because basically, initially, the letter that they typed, I believe, went through the switchboard first.
I think it went through the switchboard last.
I think it went through first and last.
Yeah.
Yeah. I think it went through the switchboard first. Then it went through the 3 rotors. So it changed in the switchboard, changed in the rotor, changed in the rotor, changed in the rotor, hit a reflector, changed in the rotor, changed in the rotor, changed in the rotor, changed in the flipboard, it came up as a light. But then the thing is, if you reset all of those things, that's the point of the reflector. Because if you now type in the cipher letter with the reset settings, it'll shoot out the plain text correctly, which is kind of nice.
And it's the same 21 2 pair for each one, right?
The same one?
The same 21 and 2 pair.
Oh, yes. Those are the numbers that are set for the Affine. See, again, that's one of the key things for Enigma versus what we're doing here. We're just doing a basic Affine cipher. But with Enigma, it was not only doing like multiple ciphers at the same time, but then it was actually changing the settings midstream. Like, the heck, dude?
We're not cracking German code. Right?
No, we're not cracking German codes.
Yeah, not yet.
Not yet. See, I gotta tell you, the people who are really cracking ciphers nowadays are the computer programmers. That's the way it has to be. They're so advanced nowadays that it really comes down to people programming something that will do the cracking for them. I do have to, about the switchboard though, I will have to double check that because it did go through the switchboard, but how many times did it go through the switchboard? Now I got to double check that. Now,
Just at the end.
now it's bugging me.
Because on the little thing, but on the thing we did, when you pressed or when you inputted it, it
a circular thing on the website,
Yeah,
right?
it went from the end, it went to thing and clicked the rotor, clicked the rotor, got to where it was going, then moved.
I'll have to double check that. Because I like the way that they visualized it on the website, because when you actually put in the letter pair for the switchboard, it actually like switched those outer letter connections. I thought that was awesome. What is this? Why did I write that down? Oh, that was for stop. Oops. Okay, let me think of this one. Yeah, that's gonna have to be it. I'm gonna start writing some of the letters. See what you got there. O was corresponding to 14. So it really should be 14 equals 21x plus 2. If I was to do that quick calculation in my head, it'd be 14 minus 2, which is 12. 12 times 5, which is 60. And then if I were to do 60 mod 26, should give me 8, which corresponds to an I. And we get the first word. Oh, it's frozen. Left my heart. There we go. I'll even do the Y right here. The Y is supposed to be a 24, which is the equation 24 equals 21x plus 2. It's supposed to subtract 2 and multiply by 5, as we talked about. 22 times 5 should give me 110. If I was going to do 110 mod 26, it should give me a 6, which corresponds to a G. And we get that first word. What is it? Tiger. Growl. Do you get the second word? What'd you get? Jaw. What's so weird about the second word being jaw? Not about the phrasing, about the decoding.
Two of the letters are the same.
Yeah, 2 of the letters are the same. That could happen. That's just circumstance. That honestly is just circumstances. Let's actually continue this out. I corresponds to an 8. No, we haven't. 21x plus 2. Subtract 2. 6 times 5 is 30. Mod 26 should give me a 4, which is the equivalent of an E. I want you to see this real quick, though. I just find this kind of interesting. can. I really wonder if there's actually like a path to this whole thing. But when you put in an E, mind you, this was the plain text. When you put in an E, it came out as an I. And when you put in an I, it comes out as an O. Now, vowels aside, I just find it very interesting that it's like, well, if I put in an E and get an I, and then I put in an I and I get an O, I wonder what happens when I put in an O. What would happen to it? Hold on. So it's supposed to be f of x equals 21x plus 2. O corresponds to 14. What is 21 times 14 plus 2? You have a calculator. 84 plus 210, 290, 294, 296. Now do mod 26 there. Mod 26. Divide it by 26. Get rid of the whole number. Multiply it by 26. Eight. Which 8 is I. Oh, wow.
Huh? It's one big circle.
Wait a minute.
Yo,
It's
No.
better than Enigma.
the Illuminati.
Is that real? How does that work?
We made a better Enigma with the mod 26.
How does that? Hold on. I'm going to double check his calculations. I'm going to double check his calculations. 21 times 14 plus 2 is 296. 296. That minus 11 times 26. No, it's 10.
Oh, yeah.
It's supposed to be.
10. Well, 296 divided by 26 gave you a decimal number, 11.38 and change, right? You are to subtract the 11 to get the decimal, and then multiply that decimal by 26. I got 10.
Okay,
Uh,
everyone do it now.
10 is a K. So it's just really interesting to me that when you put in an E in plain text, it comes out in the cipher as I, and then when you put in I, it comes out as O, and when you put in O, it comes out as K. I don't know, I just wanted to see if there was like a connection between it all. I find that very interesting. That's your rationale. I got 10, and I'm Josh. Anyway, back to this. Let's see. V was 21. Again, once you kind of get the hang of it, you don't even really have to like write out a lot of this stuff. Yeah, I mean, you can if you want to, you know, but it's like you could save yourself time. It's like, okay, 21 minus 2 is 19. 19 times 5 is 95. 95 mod 26 is 17. 17 is R. And clearly you get the word tiger. Actually, it's tigers. Q was 16. Let's see if I can save a little time here. 16 minus 2 multiplied by 5 is 70. There we go. Divided by 26, get rid of the whole number. Multiply by 26, you get 18, which is the correspondence of S. Now the J, this is where things get a little dicey, because J just goes onto itself. J is a mapping. 9 minus 2 is 7. 7 times 5 is 35. 35 mod 26 gives you 9, which is J. That's, again, like very weird to me that they would have like a mapping onto itself. I think they even said like Enigma's flaw was that you could never get a letter to be itself or something like that. Yeah. That is interesting. So again, if like that was the flaw along with knowing what some of the words would be. Like if the last couple of words were, you know, Heil Hitler, they would know, well, that's a couple of H's in there and a couple of E's and a couple of I's and a couple of L's. So if we know, we can kind of figure it out from there what that code's supposed to be. Anyway, C corresponds to 2. Now here's something interesting about 2. What's 2 minus 2? Times 5. It's 0. Mod 26, it's still 0, which is an A. Just keeps going. W is 22. 22 minus 2 is 20 times 5 is 100. 100 mod 26. Come on. Is 22, which is W. Tiger's jaw. Tiger's jaw. Wonderful. I want to show you something on Excel. Now, this could work on Google Sheets. Do you guys actually have Excel on your Chromebooks? But you do have Google Sheets, right?
Yeah.
Okay, I'll show it to you on Google Sheets then. Don't worry about having to write anything down or type this out. I just want to show you this on Google Sheets.
We have Excel. We do have Excel.
You do have Excel?
Yes. Surprising.
Okay, then I'll do it on Excel. It'll work on Google Sheets all the same, but I wanted to show Excel because it actually does show a lot of the formulas, like in little pop-ups.
You know what? Excel.
I don't think Excel.
Like a class that teaches you how to do this stuff. Yeah, like I took in high school.
You did? Wait, what?
Yeah, I know. Anyway, check this out. Look what I'm typing in right here. What I'm typing in are the numbers of the cipher text that I gave you. The LOYIVQJCW. In fact, if it helps, I can throw this to the left right here. LOYIVQJCW. There we go. Let's make all of those centered. There we go. Nice. Okay. Anyway, so here, let me insert a row up here. This is the cipher. This is the cipher number. And here is the calculation. Now, the calculation that we know of, check this out. Watch this. Equals. I'm going to type in a formula. We really need to be taking this number, subtracting 2, and then after that subtraction, hold on, come on, little thing. After that subtraction, we are to be multiplying by 5, correct? Now, if I do that, I get 45, which I know this. Now, check this out. These numbers should look very familiar. Watch what's about. This is going to be a magic trick. You ready? Yeah. But aren't those all the numbers that we got? Function in here. Watch this. Equals mod. It says returns the remainder after numbers divided by a divisor. So parentheses. I do the parentheses, and it tells me what order I should type them in. The number, comma, the divisor, which is, in this case, is 26. I hit enter. It gives me a 19. Isn't that what we got for the first number? Boom. There's the rest of the numbers.
Just like that.
Yeah. So now I can actually combine these steps all in one. Check this out. I could combine all these steps in one. I can get rid of that row, get rid of this real quick. Instead of doing that calculation, I could say, okay, mod that number, comma 26. Boom. I just put it all into one function. It just does it automatically. So this is the plain number. Boop. And this is the plain text, which the plain text we know is TIGERSJAW. Just kind of nice. It does it for you if you know how to use those formulas. I got to tell you, like, I've been using formulas in Excel for like the longest time. I'm going to show you one small thing as a resume. Check this out. I'll show you a resume. Fantasy, let's say, seasons this past season. Okay. So this was this past season in my brother-in-law's fantasy football league, right? Now, what happens is, you see, this is called the weeks. And what I do is I just type in the name and the score. That's all I type in is the name and the score. The name and the score every week. So all I have to do is type in that much information each week. That's all. And then when I do that, standings, look at these formulas right here. You see the formulas at the top? These formulas are automatically done for me, automatically calculated and automatically sorted based on how I type them in. It's insane. I have a ranking system for that too. A ranking system that kind of goes into it. I also have an automatic playoff bracket. And if you go to the individual player site, check this formula out. It actually combs through all of those weeks. See all that writing at the top? That's the formula. Yeah, I typed that by hand. Well, I mean, I didn't type. There was a lot of cutting and pasting based on previous things that I had typed. Well, the thing is, I took a basic formula that looked into the weeks thing and found the individual's name. The individual in this case was Carl Williams. It looked through that column of weeks and tried to find his name. Then it tried to determine whether or not he was in an odd row or an even row. Because if he was an odd row, then his opponent was directly below him. And if he was in an even row, his opponent was directly above him. Then it tried to compare the scores, which you can see then it tried to return the name and then go to the next one. Then it tried to return the team score, the opponent's score, and then it was very easy to do the calculation for the win, loss, or tie. And then I figured out this formula for true win percentage. That's actually a Markey original. And then I did a whole bunch of other stuff. No, not that I destroyed my opponent, but that I was trying to be the stats guy. Excel is very helpful. Anyway, back to this. Well, I'm just saying, Tiger's Jaw, it works. Now, the thing is, it's kind of a pain if I gave you something that wasn't 9 letters long, but instead, what if I gave you something that was like 30 letters long? Right? Yeah, there probably would be something that was repeated. And if there was something that was repeated, you could do that. But it's kind of a pain to have to go through all of that. You know what I'm saying? You could also, if you wanted to, create a cipher alphabet. If you notice at the top, what I wrote on the board is I wrote down the plain alphabet, but you could figure out what the cipher alphabet is and then just use that for one-to-one changing. It's kind of nice. There's a whole bunch of different ways to go through it. So I have a small challenge for you that I'm going to actually do with you. Let's write down, here it is. Let's write down this particular cipher example. Example. VNY DSLY EV VNY OSLOAQ KEQ SRVYRQY. Now, as Logan mentioned earlier, you could do frequency analysis on this. You honestly could. You could totally do frequency analysis. Well, I mean, like, for example, like this right here, it's like that could be the word the or how or and you could make that guess and then start filling things in and see what happens. You know, this could be the word, you know, or it or is or of or as or whatever, you know, like 2-letter words. You do all that stuff. This could be the word and. I don't know. I have no idea.
Never know.
Yeah.
Trial and error.
You could. Now, imagine if I told you that you had to solve this using an affine cipher. What's missing? If I told you to solve this using an affine cipher, what else might be helpful? The numbers. Yeah. Now, here's going to be the deal. Today, I'm going to be nice. Today, I'm going to give you the numbers. We're going to create a cipher alphabet, and then we're going to kind of go from there. I'm going to show you how to do this in Excel. Or if you want to do Google Sheets, I'll show you in Google Sheets.
It shouldn't be different.
It shouldn't be, but I want to create the Cipher alphabet so we don't have to go letter by letter to do all the calculations. But here's the deal, though. Next time, I won't give you the numbers. And you'll still have to figure it out using an affine cipher. Yeah. It's going to be nice. So, today I'm going to be nice, and I'm going to tell you that the numbers are 5, 4. Those are the numbers. So, you can open whatever you want, Excel or Google Sheets. I'm actually going to open a Google Sheet here. Let's see, new Google Sheet. Here we go. Okay. Now, you could do this in one of two ways. You could, if you wanted to, type in all of the letters, where you go like A, B, C, D, E, all the way down or whatever. Or you could try to do this, like I said, letter by letter. But one way of doing it, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. So you could do that if you wanted to. Just don't mess up your letters. You all know your alphabets, right?
Of course. I sure hope so.
Now you don't sound so sure. But this could potentially be your plain text. Now, for the sake of argument, I'm going to type in the numbers 0, 1, 2, 3, and I'm going to stop right there for a moment, because I don't know if you guys knew this or whatever, right? But if you type in a few numbers and you like click and highlight those numbers, you see how it's like surrounded by this little blue bar with a little square?
Yeah.
When you bring the mouse over to the square, it gives you this plus sign. You can do one of two things at that point. You can click and drag, or you can just double click. Double clicking will only work if you have something in the first column, but clicking and dragging will definitely fill in as many numbers as you need. Josh, you asked me before how I centered everything. It's just an aesthetics thing. You don't have to do this, but if you click the top left right there and highlight everything, there actually is an option here in Google Sheets to center everything. Yeah, it does. You can do the same thing in Excel. Watch, I'll show you in Excel real quick. In Excel, I'll have to zoom back out a little bit. Get rid of those. Get rid of those too. But I got to do... Actually, no, I'm going to cut and paste these letters. Hold on. I'm going to cut and paste A to Z, so I'll have to retype them. Copy, boom, paste. There we go. I'll match the formatting. Match it. There we go. Good. And then you can type in 0, 1, 2, and then click. It's a little green here, but it's still the plus sign. You can click and drag, and it goes down to there. It's kind of nice. Now, here's what you can do. In this column C, I'll zoom in so you can see what I am typing in. Come on, why aren't you zooming in? What the heck, thing? Zoom in. There we go. If you click equals, you can begin typing in a formula. And the way that this particular formula works is 5x plus 4. Where it's like, okay, well, 5 times... Oh, it gave me a parenthesis. Times, there we go. This number, and you notice I just clicked on that 0, but it gave me B1 instead. Plus 4. If you hit enter, it does that. Now in Google Sheets, they give you this thing called suggested autofill. You could do that if you wanted to. You could totally do that. Let's actually do that. Boom, and it autofills everything for you, which is kind of nice. But those are not the numbers that I need, right? What do I need to do to that column of numbers? How?
No, you go to take the mod.
Mod. I got to mod 26 this thing. So, no, watch what I'm going to do here. I'm going to do equals mod. Now, if you type in the first few things, it gives you a few suggestions, right? Now, in Google Sheets, The first one, they do have this thing that's mod, and they do have something that pops up that gives you the thing, the dividend and the divisor. It's not as straightforward as Excel. They're trying to be Excel, but come on, Excel's so much better at this. But it's the number C4, or C1, I should say, but comma, and then 26 is what you're dividing by. See, it says dividend and divisor, but they give you some definition down there. The number to be divided, the number to divide by, close the parentheses. And it does that with a suggested autofill. I'll show you in Excel in a moment. And it autofills that sucker. If I go back to Excel, like I said, it does the same thing. Equals this, I should say 5. 5 times this plus 4. Double click, it fills it in. Equals mod parentheses, and it says number and divisor. You okay? And divisor, boom, double click, and it fills it in. Then it's just a matter of filling out my Cipher alphabet. By the way, Josh, you want to know a cool new trick? Watch this, ready? Highlight everything. Bring the mouse in between 2 columns. See how it's in between the 2 columns? Double click. It is kind of nice. I could also, if I wanted to insert, I could say this is my plane. This is my plane number. This is my Cipher number. I'm going to highlight everything again, double click, and it's going to do that. It's kind of nice.
Gosh, that's so useful.
I know, isn't it?
Just in general.
It is. I honestly can't believe they haven't taught you any of this stuff. I used to mess around with Excel all the stinking time. Yeah, not just because I've used it to like I've used it to keep track of the 14-year history of my fantasy football league. Yeah, it's one of the leagues I've been in. I've been in another league for like 8 years. I just have the formulas, and then once I have the formulas, just type in the weekly things and everything else updates. Anyway, for the Cipher, again, I'm just going to kind of go through it one at a time. Let's say our ABCs. First of all, where is 0 on here? There's 0. A, B, no one's singing.
Hey, Josh.
C, D. See, this is a little bit. Hold on, I lost where E was. Oh, E, F. You got to make sure you hit enter. G, H, I, J. J is 10, right? No, J
is 9.
J is 9. So what did I miss?
Oh, man.
I've already missed something here. Hold on. What's I then? I is 8.
I is 8.
H is 7. So I should be 8. That's what I missed. Okay. There we go. H, I, J, K. See, this can be a little bit tedious. Am I right? Yeah. L, M, N, O. But once you get this, P, well,
using that code
Q, well, yeah, using this particular cipher.
up to and including
Right. R,
the
S, T, U, V.
Just be honest, you could probably crack it with Google Sheets.
Well, today maybe.
I mean, you know,
Y, and Z. There we go. Now, like I said, it can be a little bit, daunting to do it that way, but once you knock out what that cipher alphabet should be, everything just falls into place. So it's like, okay, now I have to decipher V and Y, right? Oops, scroll down a little bit. First of all, what's VNY? Okay. VNY, you know what it spells? Oh, it spells the. And from there, I can begin filling junk in because I see that VNY. So I'm just going to begin filling in the VN and Ys that I see. VN and Ys. VN and Ys. I don't see any other N's. I don't see any other Ys. I don't see any other V's.
How is V and Y the?
Yeah, it's the. Well, let's see what DSL is. D is an F. S is an I. L. Where's L on here for the cipher? There it is. It's an R. So you know what the second word is? The fire. So could be is. I'll double check that in a minute. Hold on, let me check in any DSL that I can get. DSL. I'm going to start filling them in. DSL. Say again? Oh, it is, isn't it? So what's E? So this is a T. So what's E?
Fire at.
Let's double check. Yep, it is. It's the fire at. Let's fill in some of that stuff. If there's any other E, there's an A there. Okay. What about OOAQ? O is C. A is U. And Q is S. The fire at the circus. So hold on. So there's an S. There's an S. Yeah. Let's go to the cipher. Hold on. K. What is K here? W. It was, wasn't it? The fire at the circus was intense. Nobody gets it.
I get it. I'm angry about it.
Circuses are typically held in tents. There he is. There he is. But now, just for the sake of argument, and I want to put right here. Yes, of course, you can use computers to help you do these affine ciphers. Absolutely. But again, what if I didn't give you that 5,4?
Well, then you would be screwed.
I'm going to show you how to do that. Well, not just guessing, but kind of like a little bit of focused guessing, where you would use a little bit of a combination of, well, you understand what affine ciphers do, but you would also use a little frequency analysis. Which, this is why up here, when you had these 2 3-letter words repeating, it's like, well, could be and, could be how, could be was, could be the. Most likely it's the. Let's give it a shot. And it was. But we'll deal with that in the future. Just for the sake of argument, let me show you this. What is a V in that alphabet? What number corresponds to V? 21. 21 equals 5x plus 4. What would you have to do to solve that? You'd have to subtract 4. Then how would you get rid of that 5? You can't divide by 5. Got to use the mod 26 table. Oh, which is right not there. Not there. There it is. So where's 5? Right here. What number times 5 gives you a 1? 21. So when we go back to here, we'd have to multiply by 21. That's coincidental, actually, that it was 21. 17 times 21 gives you 357. But of course, that is mod 26. So if I were to do that mod 26 thing, get you 19 right on the dot, which 19 corresponds to what letter? T. Which we knew that because it was the word the. So like I said, you could either go through that calculation. How many times? How many? I don't even know how many letters were up here. But of course, a lot of them were repeated letters, right? You could go through that calculation a bunch of different times, or you could learn how to use Excel or Google Sheets. Just saying. I will go through the Google Sheet thing again with you, but it can be a huge help to kind of go through these things rather than do them a piece at a time. There are ways. Now, some of you guys are in computer programming. I know you are. Who? Anyone else? No? All right, whatever. But in Excel, you can actually do like small, you can program certain functions into Excel where you could be like, I believe, and I've done this a few times in Google Sheets. Let me see here. In Google Sheets, there is a way to, where is it? Oh, yeah, there it is. You can do like a script editor or program in a macro. And you can actually do this thing where it's like, oh, it creates a brand new function that you can now use to do whatever the heck it was that you programmed them to do. It's insane. That's why Microsoft is so much better at this kind of stuff. But anyway, I digress. We're going to pick up with more Affine the next time. To kind of wrap up today, like I said, I am going to be sending you or assigning you that imitation game, little quiz thing. It'd be a minor. But like I said, you'll be able to do that. But I do want to give you also next, maybe I'll hold off on the veneer or the veneer. Veneer. Actually, you know what? Okay, I changed my mind. This is how much my brain is changing today. I'm not going to assign you the enigmas today because I wanted to spend some time going over Veneer and Playfair with you, but there's not enough time to do that today. So I'm going to hold off on that till Monday. And instead, I am going to assign you the imitation game quiz, and you can begin working on it now because we have roughly 10 minutes left. So let me do that. I got to find the imitation game thing here. Where is it? Oh, there it is. Subjects, cryptology, imitation. There it is. Cool. Okay, so I'm just going to type in your instructions. Your task is to answer these multiple choice questions about the film The Imitation Game. I would like your answers on a Google Sheet, Google Doc that you will attach to this assignment. It is due by 7:30 a.m. Monday, May 10th. So let's see. Imitation game minor. Let's see, 7:30 a.m. Assign. Boom. in your Chromebooks, and you do have 10 minutes right now, so I would like you to take a little bit of time right now and to read through some of those questions. And like I said with the directions, I would like my answers on a separate Google Sheet that you are going to be attaching. It is going to be due Monday. Yeah.
I wish there was a PDF reader that the school would use that wasn't bad.
Yeah.
And then I could actually attach to the thing.
I know. Josh, I have a question for you. How many holes are in your shirt? No, I'm just saying. I just nodded.
Yeah.
Yeah.
Right?
It's 4.
4?
Yeah.
I hope you have 2 arms.
I mean, even if you have 1 arm, it's still
Well, that's provided.
Yeah.
Does a straw have 1 or 2 holes?
Does what?
Does a straw have 1 or 2 holes? But it goes all the way through.
Well, so does your shirt.
Yeah, so is your shirt.
Yeah, that's why.
But if it only had 1 hole, then nothing would go in.
You have 2 arms.
But I'm just saying in terms of like, if you said that there was a hole in your shirt, you'd say like, oh, there's like a tear in your shirt, right? It's the same concept. That's just 1 hole, which is why for a straw, you do have to say it has 2.
I've heard people say there's 1.
Well, they're kind of like slow.
Follow-up question. How many sides does a triangle have? How many sides does a quadrilateral have?
4.
How many sides does a circle have?
Wait, a circle?
Infinite many.
I love the different answers.
That's Bill Nye.
Bill Nye
would know. Actually,
Bill Nye wouldn't know. Bill Nye's kind of.
Most mathematicians would tell you that a circle technically has an infinite number of sides, although infinity is not a number.
So it has no sides at all.
It's got a limited.
Well, you could say, hold on, watch this. It's like, what is that, lint in my pocket? Cool. You could, right. So like number sides of a triangle equals 3, right? That's a very basic thing right there. You could say the limit of the number of sides of a circle as sides approach infinity equals infinity. That's what you could say. The limit is approaching infinity. Yeah, but you can't say that it actually is. A what? I don't know what that is.
So it's a zip file that you download, and you send it to someone, and then they open it. When they open it, it's 16 files containing 16 files each, which each contain 16 files,
Mm-hmm.
which each contain 16 files, and it comes out to around a lot, like terabytes of storage. It just crashes your computer.
It probably wouldn't even let you attach it in the first place.
Well, it's only like 50 gigabytes because it's in a zip.
Mm-hmm. So it probably wouldn't allow you to extract it.
Well, I've seen.
It's too big.
No, zip files.
Yeah, I'm just saying, but then you have to extract the files from the zip drive.
You can do that. Maybe on Chrome you can't, because my friend tried to do it in English class and it just stopped him.
Ah.
But then it actually downloaded, which is weird. But
Get to work. You guys got about 5 minutes before I walk you down to lunch and I tell you to make new friends. It's what you say to a kid when you send them off to school. Make a friend today.
One time someone said I want to be a friend.
You're
That's
right.
like, oh.
Birthday.
I was like, I see you, I guess. Sorry, I just don't want to be.
By the way, the funny thing, I was supposed to be observed again today.
Oh, yeah, they probably just missed a good class with the numbers and stuff.
Yeah.
Well,
Whatever. Anyway, back to work.
It's like, still says no. To this day.
What's interesting about the Affine cipher is that if you do have a longer message, it makes more sense to figure out what the cipher alphabet is, the entire thing. But if you just have a short message like Tiger's Jaw, it doesn't really make much sense to write out that entire alphabet. Wouldn't you agree it took us about the same amount of time for Tiger's Jaw versus the Fire at the Circus? Yeah. It's intense.
I feel like it was like 20 days. We just made up all
When you become a dad, you actually get a book from the federal government about
You have to say
dad
that.
jokes.
Best dad jokes, 2021.
2021, you have to say these or else you die.
No, there's a fine in your taxes.
President of the dad joke in the mom.
It's over. You got 4 minutes or 3 minutes. Yes. For you guys in the live stream, I'm going to be signing off because I got to bring these guys to lunch. I hope everyone enjoys the handcrafted sandwiches and the notes that I left you. And we'll see you next time. All right, let's go to lunch.